The fourth type of reaction we're going to talk about is the double replacement reactions. Double replacement reaction is similar to single replacement reaction, but this time you have two compounds, two aqueous solutions reacting together. So let's go back to our dance. Alan and Betty also went to the same dance as friends, and Chris decided to go with his friend Dory to the dance. They went in the same dinner group. During the course of the evening, they all realized that there was a lot of attraction with each other's dates. By the end of the dance, Alan and Dory were spending all of their time together, and Chris and Betty were also inseparable. They all felt lucky to have gone in the same group and to be starting their new romances. This turn of events can be summarized by the following, right? We've got AB, Alan and Betty, and CD, right? These are your reactants. This is how they go to the dance. But at the dance, a reaction happens, and then we've got AD plus CB. We have a switching of partners. Now you can see that in our general equation, right? So our general equation is AB plus CD, and that produces AD plus CB. Now keep in mind that when you have these ionic compounds, it's the cation will switch with the cations, right? So if this is my cation, it will switch with this cation, and so you can see we have AD and CB, right? So you have your cations and then you have your anions, right? So you hear your anions, okay? And so when you're switching places, you have to make sure that you are giving them the correct partner, okay, when they switch. Now, in your products, only one product is soluble, whereas the other product will be a precipitate due to low solubility. Now, a precipitate is a solid that is formed in solution. Usually ends up looking kind of cloudy in that solution. So you want to make sure that you know your solubility rules, and that will help you to predict which product is going to be the precipitate. Let's look at a couple examples. So we have solutions of aluminum acetate and calcium hydroxide. So let's write our reactants. We've got aluminum acetate. Make sure you know how to write your formulas. And this one is aqueous. And it reacts with calcium hydroxide. Okay, and that produces aluminum, and its new partner is hydroxide, and calcium's new partner is acetate. Okay, now when you look at your solubility rules, you'll see that this is going to form a solid, and this one is aqueous. Okay, and then you go back and balance it. Okay, and so this is my balance reaction for this reaction. Okay, I'm going to actually skip this reaction, and let's look at number 3 in your packet. So we've got solutions of potassium nitrate and ammonium chloride react to produce. So we're going to predict the products for this one also. So we've got our potassium nitrate, and these are all solutions to start, and it reacts with ammonium chloride. And it produces, okay, let's predict my products. So potassium's new partner is chloride, and ammonium, the new partner is nitrate. Okay, now when you look at your solubility rules, you would see that this makes an aqueous solution, and this makes an aqueous solution. And as we get into ionic equations and net ionic equation, you're going to see that all you're going to have before is you're going to have a bunch of ions in solution, and all you're going to have after is a bunch of ions in solution. And so really no reaction is happening because all you have are a bunch of aqueous solutions where nothing is actually forming. You're not forming a solid or a liquid or a gas, and so you would write NR for no reaction. So you always make sure you look at your solubility rules and know how to use them to determine whether a precipitate is formed. So now you're going to do the mini lab and some extra practice as well as coming up with the solubility rules in lab.